So after the installation, this icon will appear on your desktop. Double click on that software and this type of interface will be appear. In this you have operation tree where various operations for the images are given. Then you have operation list.
Sir? Sir?
Yes.
Sir, I have pasted the patch in the exact folder which you said, but then too it is asking for the registration number and all.
You have to correctly navigate to the installation folder of Ilvis. And select the file Ilvis 30.
So Ilvis 3.3 in Ilvis 3.3 folder we have to paste.
Yes, you can go like that. In the C folder, go to the program file and
Yes,
you
sir.
will see a folder Ilvis 3.3 academic.
Yes, sir.
In that folder, you will see the file name Ilvis 30. This blue icon, green
Yes.
icon, this application. You need to select that in the patch.
Achha. So during pasting, we have to select that folder.
No, you don't need to paste.
What then?
You have to run this patch.
Achha,
After that,
but
it will ask for the file.
sir, in my one it is showing patch 331.
Yes. See again. This is the patch 331. I
Yes,
am
sir.
clicking on that and then it will ask for the file.
Okay. Then we have to navigate to that to the patch.
No. Navigate it to the Ilvis 30 file from the installation folder. Go to the C and program file. Then you will see a folder Ilvis 3.3 academic. After that, you will see the Ilvis 30 file. This is the Ilvis 30 and click on open. Then it will ask yes, click on yes, again click on yes, then it will be updated. You need not copy and paste the patch anywhere. You just click on that and it will ask for the file and provide the file Ilvis 30 to it while navigating the installation folder.
Yes, sir. It is done.
Okay. Anyone facing problem in the installation? You can again ask. Okay, the first step in the doing experiment is to make a one. Yes.
Sir, what is UG data? 6.rar.
Yeah, this is the data that will be used in the experiment. You need to download it and place in a folder. After that, I will tell you how to perform experiment using this data. Okay, have you downloaded the data?
Yes, sir. Extracting the files.
Okay, extract the files and place in a folder in the
Yes.
desktop. Okay, like this, I have made one folder and put the UG data 06 on that and chapter 6 file. It is mandatory to make a folder with the data, so it will be easy to navigate for the image processing purposes. So as you can see, this is the interface for the Illus software. It has operation tree navigator. Using this, we navigate to the specific folder. And using this button, you can also navigate to the folder. Suppose my data is in the desktop, on the desktop. So we can click on the desktop and we see the folders present on my desktop. In the desktop, I have made one folder named RS1, remote sensing 1, and in that folder we have placed our data. Then you can select the UG data. These files will be displayed in the catalog. So first you need to perform up to this and navigate the folder to this catalog. And in this interface, we have operation tree. So in the operation tree, we can see the statistics. In that, we have the options histogram, raster, map list, polygons, segments, and points. And many other operations can also perform on the images. So the need for this experiment is to just visualize the images and perform some statistical operations on the images. You can also continue along with me. So if you are facing any difficulty in the any step, you can ask again. So we will try to open the TMB1, TMB2, TMB3 up to 7 bands of images. So we open the TMB1 by double clicking on that and we see a window. In that we have that we can see the minimum value of pixel or DN value is 25 and the maximum is 162. And in the representation we can select the different options. I am selecting the gray and click on OK. So this image is displayed, and by clicking on the zoom in button we can zoom the image up to a pixel level, and using the minimize button we can minimize the size of image. In this way we can display the multiple images together, and we can minimize this window and again click on TMB2 and this image will be displayed and place it at a corner. So At the same time, we can display the two images and compare the images. Suppose we want to open the spot images. So this is the image for different area, and in this way we can compare the different images by placing it on the different locations on the desktop. This is the visualization step. After that, we need to perform the statistical operations on the images. For the statistical operations on the images, we can go to the operation list. Sorry, operation tree, and we can click on histogram. For the histogram, we need to select a map. Suppose we want to see the histogram of the TMB1 image. So this window will be open. In this, we can see the mean of these DN values, standard deviations, medians, and minimum and maximum value of the histogram. And we can see the most of the points of this histogram are lying within the 25 to 100. And we can also see the number of points in the image. We can see the area and maximum value of DN and minimum value of DN.
Sir, please, can you one more time tell me from where you have brought this, because volume and audio and video synchronization was a little bit disturbed.
Okay. So suppose we want to do the statistical.
Mukesh, sorry for the interruption. Could you please just once again show the step of opening the image? One concept I would like to discuss, like visualization of single band image. Just repeat the process.
Okay, sir. Okay. First, you need to navigate to the folder you have made on your desktop for the data within it. Then click on OK and navigate to that folder. And in that folder, you can see the different images, spot images, TM band images, and double click on that. You will get
okay, wait. See, you can see over here the multiple image files. Okay. So images are acquired in a different band. As in the theory class, I discussed that in the electromagnetic spectrum, what we do, the satellite-based imaging by using an imaging sensor. So the imaging sensor is designed in a specific band. When we consider our own vision system, so our eyes are sensitive within 3 spectral band, red, green, and blue. Okay, our eyes can't sense the incoming radiation from an object beyond visible spectrum. Fine. So there is a limitation. Our eyes can only sense the reflected energy coming from the object, like sun is an external energy source. Okay, lights are coming from sun in a very wide spectrum. Okay, after that light interact with the object, Like let's say we have a two object, trees and building. So after interaction with the object, there is a reflected energy. Okay, so we see the object on the basis of energy content in the reflected energy. This is a very generic and basic principle to see the color of the object by using our own eyes. Okay, so the energy reflected back from the object are there in all the spectral band. Okay, that energy will be there in a visual spectrum, it will be in the infrared band, it will be in microwave band. Okay, but our eyes filter out all the energy content outside the visible spectrum. Eyes only sense the energy content which is reflected from that object within visible spectrum. Fine. So if we consider the visible spectrum, there are three distinct spectral bands within that, in red band, blue band and green band. Okay, so once the reflected energy in green band, red band and blue band are sensed by our eyes, okay, so there is a synchronization in the color assignment. Red band is assigned red color, blue band is assigned blue color, and green band is assigned green color. Okay, and we see the photograph, we see the image of different objects in that way. Like in if we consider the trees, the reflected energy is dominant in green band. So the composition of green, this is dominant. So that's why we see trees green in color. Okay, but in this case, when we apply the same concept using the artificial remote sensing techniques, okay, like through satellite imaging, artificial satellite imaging system, we capture the images, then on your PC or laptop you open the images. Like what you are going to do over here in this step, using a software, okay, an open source software, that is Elvis, you are going to just visualize a single band or multi-band images. Okay, so there are inbuilt step in the software that take input image and assign the color to each pixel. If we open a single band image, then uh, that pixels are read by the computer, and at each pixel location that you see, it's a grid. Okay, it is painted, and now you see the image. So the process where we assign the color, that can be changed over here. Like in our case, in our vision system, it's very fixed. Red band will be assigned red color, green band will be assigned green, and blue band will be assigned blue. We can't change. Okay, but by using your PC, laptop, you can change the combination of color assignment. Like red, green and blue color can be assigned, let's say energy in red band, okay, and corresponding pixels can be assigned color in blue band. It can be done. Okay, so first of all, understanding of in how many spectral bands images are acquired by artificial remote sensing tools. Okay, like in our own vision system, we have only three bands, fixed three spectral band. But in artificial remote sensing techniques, we can acquire images in multiple bands. Okay, extending from visible spectrum beyond to let's say microwave band. So very large number of bands, the images can be acquired. The data set which is given over here, just you need to explore in chapter 6, like how many bands are used. Okay, so in a particular satellite imaging program, the images are acquired. Okay, just you need to see that how many bands that data set is collected first. Okay, in which spectral band the data set is collected, images are collected, and what is property of that spectral band. Okay. Now, this is the first thing you need to understand. Then after that, for the visualization, okay, let's say if you are selecting a particular specific band for single band visualization, okay, so you select a band, then the pixels, the this digital number corresponding to each and every pixels are read by the system, and a grayscale value, a color set of grayscale is assigned to that. Mukesh, just select one band and just visualize the image. Open the image. Let's say TMB1. Select TMB1. Wait. Just go back and just show me the option that is coming. I need to explain that part. Yes. Select TMB1. Wait. Okay. So just see that grayscale is selected for the color assignment. Okay, it means this is a single band image. It is selected. Okay, and we have a pixels, and pixels are characterized by digital numbers. Okay, so each and every digital number is assigned by a set of grayscale in this process. Okay, so this is a step you are doing, but what I expect, like, you need to understand this how the pixels are, how a digital number is assigned to each and every pixel. Okay, and once you are selected a particular band, so how for each pixel a color is assigned, grayscale color is assigned, whether it is a linear assignment, it is a non-linear assignment. Okay, let's say we have low digital numbers like close to 0. Let's say we have in band 10 to 20. So will it be white in color towards the white side or towards the black side in different sets of grayscale? Okay, so all these things are for the understanding. Now click on OK button, Mukesh. Okay. Now this is the grayscale image for that particular site from where this image is collected. Now Mukesh, perform one more step. This color image. Select 3 band. You can start fresh, like select 3 band and then 3 color will be assigned. Okay, let me explain first. You will do it later on.
Okay, sir.
Okay, see, for the color image, you need to require 3 band at a time. Okay, you know that there are 3 primary colors: red, green, and blue. Okay, so though using the satellite imaging system, images are required in many spectral bands more than 3. Okay, let's say it could be 12 band, it could be 200 band. Okay, but for the color image visualization, only 3 bands can be visualized at a time. Okay, so out of n band which are more than 3, you need to select 3 bands. Okay, and each band is given a out of 3 one color. As I said, in our own vision system, red band is assigned red color, green band is assigned green, and blue is assigned blue color. But it is not there. In this case, you can change the color combination, and all you do for the better interpretation of objects in the image. Like you see that our eyes are trained to see trees green in color, but it will not be the case over here. That's why you need to train yourself to understand images or to interpret the images after the visualization. Let's say if we are going to see, if we select 3 band in near infrared band. Okay, let's say one band we select in near infrared, another band in mid infrared, and third one is far infrared band. Okay, and then in that case, if you assign red, green, and blue color, so you might not see the trees green in color. Okay, because see, it all depends. Basic concept how color is assigned. If we consider our own vision system, trees reflectance is highest in green band. If we consider 3 bands, red, green, and blue, in green band, trees reflectance is highest, and green band is assigned green color. This is the reason why we see trees green in color. Okay, but when we consider out of the bands out of visible spectrum, let's say near infrared band, mid infrared band, and far infrared band. So in that case, let's say our object of interest is trees, then first you need to see in which band trees reflectance is highest. Okay, and the corresponding to that band which color we are assigning. Okay, so in the band within like out of these 3, near infrared, mid infrared, and far infrared, in which particular band trees reflectance is highest, and after that at the image opening step in a particular window, which color you are assigning to the bands in which the trees reflectance is highest. So that in that color trees will be displayed in the image, and without this understanding you can't interpret like this color is this color represents trees, this color represents building, and some other objects. Okay, now this interpretation is on the basis of training. Like you need to train, you need to understand the concept, you need to understand the object's reflectance behavior. Okay, in which band what is the reflectance of object. Okay, then after that at the image display level in a window, what is the color combination is chosen to assign the color to the band. Okay, so this is the motive behind this experiment 1. Like you understand first of all the given number of the in the different bands images are collected. So read chapter 6 and just see that what is the characteristic of those bands in which images are collected. Okay, whether they are 7 band, 12 band. Okay, then after that you need to explore how many objects are there in that particular test site, let's say it is shown over here. It's just like you can't interpret, okay, if you don't have understanding. Okay, it's just sets, different sets of gray color. Okay, so you need to understand how many objects are there, what are their reflectance behavior in a multiple bands. Okay, so you can zoom it, you can zoom out. Okay, so zooming in at a certain level, after that it will be pixelated. So further you can't interpret much more. Okay, we will discuss about why after a particular level of zooming, okay, it becomes pixelated, like you can just see the square blocks painted in a different sets of gray color. Okay, so visualization means just not only just clicking the button, selecting a particular option and opening the image. It is all to just see over here. Once you zoom it at a very detailed level, you can see different sets of gray color, okay, which are used to paint a square block. Okay, so now Mukesh, you can continue. And further, I think this, after the opening, even you can analyze the statistics of the image, like in the very last when I started discussing about this. Before that, there was discussion on image histogram. Okay, so image histogram will be discussed, and I hope you have understanding of histogram. Let's say if we have a certain set of numbers, okay, and most of them are repeated. So let's say we have a number from 0 to 255, okay, and these numbers are given in a set, and most of them are repeated. Let's say I explain it in more detail. In a particular set A, we have 1,500 numbers, and those numbers are chosen from 0 to 255. Okay, from 0 to 255, the numbers are chosen. Okay, and they are used in a set which is having total number 1,500. Okay, now if you want to plot a histogram, then in the histogram it's a two-dimensional representation of a data, where on the independent axis, that is x-axis, you have a number from 0 to 255, and on the dependent axis, that is y-axis, you have the frequency component. Like let's say if we select 0, then how many times in the set A 0 appears. Okay, similarly if you select 5, then how many times 5 in a set A appears. So it will be plotted in terms of frequency. So frequency versus these number from 0 to 255 depiction on two-dimensional axis system is called a histogram. Okay, similarly other statistical variables we have to represent an image, that can also be calculated, and that will also be analyzed in this experiment 1. Fine, is there any query? Okay, so Mukesh, you can continue now.
Thank you, sir. So for the image visualization, you can go to the new catalog and navigate it to the folder you have the data. I have the data in the RS1 folder, and you will see the different images present in the data. So for the visualization, we need to select the images from the different bands. In the TM band map list, we can see there are 7 band images, and we can open the images to visualize and compare the images. We can also open the multiple images on the desktop at the same time in the different windows. In this way, we can compare the images by just placing by side, and you can compare the changes in the images. In this way, multiple images can be placed in the desktop for the comparison purpose. And after the visualization, you need to perform some statistical operations on the images. For the statistical operations on the images, you can go to the operation tree, and in that you have statistics option. In that you can select the histogram, and from the histogram you can select the TMB1 image, and you can visualize the histogram of this TMB1 image. In this histogram, many things are calculated, like number of pixels, standard deviation, mean of the pixels. Means we can see the average value of the pixels is 49.02. And you can also see the total area has also been calculated, and you can also see the most of the pixels are lying within the range of 25 to 100. So you can perform this step at your end also, and you can note down the few things like what is the mean of this these DN numbers, what is the median, standard deviation, number of pixels, total area, and minimum and maximum value of the pixel. In the same way, you can also see the statistics for the TMB2 image. For this, the minimum value of DN number is 7 and maximum is 94. And the previous band, these values were different. And the histogram can also be shown by going on the options section. So in this way, only the histogram will be displayed, and you can select the TMB2 image by going to operation tree option. In this way, we can see the most of the pixels are lying within the 0 to 50.
Sir?
Yes.
Sir, what is TM number which you said to note down? What is that, sir?
You can note down for the TMB2 image, the mean of the pixels is 26.22, standard deviation already given, and the area, total area, covered in the image, total number of pixels in the image, and the minimum value of the pixel is 6 and maximum value of the pixel you can see from the list. Minimum value
Sir,
of the
what will
pixel.
be the
Yes, yes.
sir? What will be the use of all these things? Means, what is the physical significance? What we are actually doing, sir? I'm not getting these things, sir.
We are just doing the enhancement for the images. Enhancement is the improving the visual quality of the images for different purpose. Suppose we have X-ray images. For that, the enhancement procedure will be different. And suppose we want the radio image or any different image captured, and we want it to be visually correct by our eyes. So different method will be used. For medical images, different procedures are applied, and for other photographs, you can use the different procedure to enhance the images. Right?
Okay, sir. And sir, what is the requirement of learning this minimum and maximum point one?
If you know the minimum value of pixels, means if the value of pixel is 0, means it will be completely dark pixel. Okay. If value is 255, then it will be completely white pixel. And all pixels lying within the 0 to 255 will be a some grayscale range. It will be gray
Okay,
pixels. Okay.
yes, sir.
So you can perform these steps at your end. After that, you can apply the enhancement procedures to these images. So you just go through the manual chapter 6 and fill the few tables given in this file. Suppose all steps are also given in this, so you can follow these steps and try to fill these tables given in the table 6.1. As the experiment is only to visualize the images and show the statistics or perform some statistical operations, so you need to do that only. Okay. In the chapter 6, you can follow the steps given from the page number 210. You can also explore the many other options given in the statistics or operation list.
Sir,
Yes,
sir, the folder which is given by sir, that is Elvis data. Sir, in that we have uh, so many different folders like
yes, yes. You need to download only one folder, UG06 only.
UG06.
UG data 06 only. In that folder, the TM band images are given. And other folders will be used in the in the other experiment.
Okay, sir.
Hello, sir.
हाँ बोलिए.
Sir, TMB2 is not showing in Elvis UG data. TMB1, TMB2, TMB3, and TMB4 are there.
You can go to the map list. You can go to the this TM band. Click on
No,
that.
sir. In that there is, but I have opened the Elvis software, so it is not
Okay.
showing there.
You have clicked on TM bands, but it is not showing the all several bands, right? It is not showing like this. Okay, you are getting this error. Okay.
Yes, sir. Same here.
Okay, okay. Have you downloaded the data from the meeting chat or somewhere else?
Which was given in the Elvis folder, Elvis data.
Okay, you can download from this meeting chat also. Here it is given separately the TMB band. So from the histogram, you can note the minimum value of the pixel, maximum value of the pixel, average of the pixel in standard deviation, and the sum of the pixels for the TMB1, TMB2, and TMB3 images.
Sir,
Yes.
sir, we have to note down the values of only npix column, minimum, maximum, average.
Minimum, maximum, average, area, and the total number of pixels, and the average also. Not all the parameters you are getting in the histogram. Okay.
Sir, means only one column, na? So npix column or everything.
Some meaningful information like minimum value is the meaningful, maximum value, average. Okay. And some of the pixels and the area. Okay. And the total number of pixels.
Sir, means I want to say that only first column is little bit uh, can be kept in mind, but all means last one, like last column of area, and their values are very big values. Can they have to be also remembered?
No need to remember that. You just note it down. You are doing the experiment, you are getting some values. So you just note it down. No need to remember that. You cannot remember all the values.
Sir, what is the meaning of this npix first column heading?
Number of pixels.
Actually, number of pixels. And sir, npix ct.
Npix, the meaning of npix is suppose 0. 0 pixel value is having 0 number of pixels. 1 pixel value
Yes.
is having 0. And from this, the pixel value 29 is having 1567 pixels, right? And this value is ranging from 0 to 255. Okay. And the minimum value of pixel is 25. The pixels with the value 25 is 11 in the number, right?
Yes, sir.
And the pixel value having the maximum value of the pixel is suppose given is 150. and the highest value of pixel is 150 and it is only 1 in the number. Okay,
Yes, sir.
and it is covering the area of 935.
Right, sir.
We can also open the images as a color composite. Okay, for the red band, suppose we have selected the band 1, green band we have selected the TMB2, and red band we have selected the TMB3. So this image will be displayed as a color composite.
Okay, so I hope you can follow the steps discussed with you for this experiment 1, as well as the uh, general things which are discussed with you. Okay, like I said before, you need to understand the setup instructions in a particular task. Okay, so while executing the experiment, if you are applying a certain task, okay, so you need to understand the setup instructions. Okay, because when you have understanding of setup instructions, you can write your own script. Okay, and I expect you to go through the basic requirement as well as the installation of software, like this installation of software, understanding of dataset given to you, and how, like with respect to experiment 1, how different set of colors are assigned to the different bands in multispectral images. Okay, so if there is any query, you can discuss.
Sir, which you were saying, learning how to write the instructions. What do you mean by that? What kind of instructions?
Okay, let's say our objective is to visualize a single band image. Okay, so first of all, to visualize a single band image, if you are going to use an application like this software, okay, so what do you do first? You just take a particular out, let's say if there are n number of bands are there. Okay, so out of n number of bands, for a single band visualization, what you will do, you will select a single band image. Okay, so after selecting the single band image, it will be given as input in the application. Okay, then different set, the grayscale you need to select. Okay, so grayscale, different sets of grayscale you are going to use for painting the pixel. Okay, so taking image as an input in the application is a particular task. How it has been done? Okay, how it has been done in this particular software. Okay, how that input image can be read by the software. Okay, let's say if you are going to write your own script in MATLAB, then what command you need to provide in MATLAB to read the input image? Okay, then after reading the input image, what you need to do, each pixel will be selected one by one. Okay, and out of let's say if you are going to use 8-bit image, so 0 to 255 different sets of gray color will be there. Okay, how you select a particular set of gray color to assign the color to that the digital number? What are the setup instructions that you need to write for that? What is the workflow? How you can code it in MATLAB? Okay, then further you click it, and in a window the image will be opened. Okay, so the image which you can see in a particular window, it's a visualization. So how that step can be separately implemented in MATLAB. Okay, so for doing all these tasks, okay, if you are going to give a command to a particular software, if you are going to write your own script, so obviously there is a sequence of setup instructions through which you can you can write your own code. Because see, by using this software, you directly do it. You just select a particular option, just input the image, that image is already, then after that image will be read by the software. Then there is a particular option, you click it, and there will be option to select a sets of gray color. Then finally, if you click it, and in a window, you can see the image. It's very straightforward. but it is not objective. Our objective is to understand what is happening inside the software. For executing all these tasks, what are the steps which are coded in the software, okay, which are implemented in the software. I hope it is clear.
Yes, sir.
Okay. So for all the experiments which you are going to execute using the ILWIS software, obviously you are going to understand how we can do it by ILWIS. That is very simple. But along with that, you also need to understand the setup instructions which are used in implementing those tasks in the ILWIS itself, so that when you know the generic setup instructions, you can write your own script in any coding platform like MATLAB, C, C++, Python, etc. Okay. So thank you. Now I'm going to stop this lecture session. If there will be any query, you can note it down, and that will be discussed in the next laboratory class. Okay.
Thank you, sir.
Thank you, sir.